A planet shaped by catastrophe. Earth is approximately 4.54 billion years old. Across most of that immense time span, life has continuously evolved, adapted, and spread, first through the oceans, then across the continents, and eventually into the atmosphere itself. But the history of life on Earth is not a smooth upward trajectory. It is marked by sudden interruptions. At least 5 times, the planet has experienced periods during which the majority of living species disappeared within what geologists consider an extremely short span of geological time. These events are known as mass extinctions. By geological definition, a mass extinction occurs when more than 75% of all species on Earth vanish within less than 2 million years, and in some cases, the collapse unfolded far more rapidly, over tens of thousands of years, or even less. Mass extinctions do not simply eliminate organisms. They dismantle entire ecosystems. Food webs collapse. Oceans lose oxygen. Climate systems destabilize. And the surface of the planet is fundamentally transformed. Extinction is not the end of life. One crucial point must be clearly understood. Mass extinctions do not end life on Earth. Instead, they bring an end to the dominance of once successful species. After each catastrophe, the planet requires millions of years to recover. The survivors evolve, occupy newly opened ecological niches, and gradually construct a biosphere unlike anything that existed before. Without past mass extinctions, mammals would never have risen to prominence. And humans would never have appeared. The first mass extinction, Ordovician-Silurian, approximately equals 444 million years ago. The first mass extinction occurred during the Ordovician period, when complex life was still almost entirely confined to the oceans. The primary cause was extreme climate change. Geochemical and sedimentary evidence shows that Earth experienced a sudden and intense ice age. Global temperatures dropped sharply. Ice sheets expanded across the polar regions, causing sea levels to fall by as much as 100 meters. As shallow continental seas drained away, vast marine habitats disappeared. The consequences were catastrophic. Approximately 85% of marine species went extinct. This event demonstrates one of the most consistent lessons in Earth's history. Rapid climate change, whether warming or cooling, is deadly on a global scale. The second mass extinction, late Devonian, approximately equals 375 million years ago. The next extinction did not occur suddenly. Instead, it unfolded gradually over millions of years. During the Devonian period, plants expanded across land for the first time. Their deep root systems accelerated the weathering of rocks, releasing large amounts of phosphorus and other nutrients into rivers and oceans. These nutrients fueled massive blooms of algae and microorganisms. When they died, their decomposition consumed oxygen, leading to widespread ocean anoxia, a severe depletion of oxygen in seawater. Coral reefs, the most complex ecosystems in the oceans, nearly collapsed entirely. Many ancient fish lineages disappeared. This extinction revealed a fundamental biological vulnerability. When nutrient cycles fall out of balance, the oceans can effectively suffocate. The third mass extinction, Permian-Triassic. The Great Dying, approximately equals 252 million years ago. This was the largest and most devastating extinction in Earth's history. Evidence shows that 96% of marine species vanished. 70% of terrestrial species disappeared. Entire evolutionary lineages were erased forever. The primary cause was massive volcanic activity known as the Siberian Traps. Over roughly 1 million years, these eruptions released enormous quantities of carbon dioxide, methane, sulfur gases and toxic metals. Global temperatures rose by 5 to 10 degrees Celsius. Oceans became highly acidic, dissolving the shells of marine organisms. Oxygen levels plummeted, creating vast dead oceans. The Great Dying delivers the clearest warning in Earth's history. Large-scale greenhouse gas emissions can render the planet nearly uninhabitable. The fourth mass extinction, Triassic-Jurassic, approximately equals 201 million years ago. This extinction was also linked to continental-scale volcanism, as the supercontinent Pangaea began to break apart. Volcanic eruptions released massive amounts of carbon dioxide, driving climate instability and ocean acidification. Many dominant reptiles and ancient organisms disappeared. Yet this catastrophe reshaped the future of life. It cleared the ecological stage for dinosaurs, which would dominate Earth for more than 135 million years. The fifth mass extinction, Cretaceous-Paleogene, approximately equals 66 million years ago. The most famous extinction event was triggered by the Chicxulub asteroid, measuring approximately 10 to 12 kilometers in diameter, which struck the Yucatan Peninsula. The impact released energy equivalent to billions of nuclear bombs. Dust and sulfur aerosols filled the atmosphere, blocking sunlight and triggering a prolonged global cooling. Photosynthesis collapsed. Food chains disintegrated. Approximately 75% of all species, including all non-avian dinosaurs, became extinct.
Based on the new data stream.
Are we entering a sixth mass extinction? Today, research from IPBES, IUCN, and Nature suggests that Earth may be entering a sixth mass extinction. Key findings include: current extinction rates are 100 to 1.000 times higher than natural background levels. Over 1 million species face the risk of extinction. 75% of terrestrial ecosystems have been altered by human activity. What makes this event unprecedented is its cause. This time, the primary driver is not natural forces, but human activity. Climate change driven by carbon dioxide emissions, deforestation and habitat loss, plastic and chemical pollution, overexploitation of species. In just 150 years, atmospheric carbon dioxide has risen from 280 ppm to over 420 ppm, faster than almost any known geological event. Lessons from the past. Earth's mass extinctions deliver 3 clear messages. First, life is resilient, but recovery requires millions of years, far beyond human timescales. Second, rapid climate change is the most powerful extinction force, regardless of whether it is driven by volcanoes or human industry. Third, small changes can accumulate, eventually triggering irreversible global collapse. An unprecedented choice. Earth has survived asteroid impacts, supervolcanoes, and ice ages. But never before has a single species possessed the power to determine the fate of the entire biosphere. Unlike asteroids, unlike volcanoes, we can choose. The question is no longer, what caused mass extinctions in the past? The question is, what will we do to ensure we are not the cause of the next one?